Hello guys, here's another density problem, and we're going to use the guess method along with the density triangle to work these problems out. So let's go ahead and read the problem and make sure we get the right things underlined. Okay, so the problem reads that rocks are sometimes used along coasts to prevent erosion. If a rock needs to weigh 2,000 kilograms, now it says 2,000 kilograms, in order to not be shifted by the waves, how big, so what is the volume? We talked about that in class. That's what, when it says how large something is, it's really asking for the volume. Does it need to be? You are using basalt, which has a typical density of 3,200 kilograms per meters cubed. So you have the density, and so far you have the density right here, and then you have the mass right here. So you know that because it needs to weigh that much. So we're going to come over here, we're going to start the guess method, and we're going to use the density triangle. So it's asking for volume, and you're given the density and the mass. So we're going to write down the guess right here, G-U-E-S-S. You're going to write down your givens. You're given the density equals 3,200 kilograms per meter cubed. Your density isn't 3,200. Your density is 3,200 kilograms per meter cubed. Another way to write that is 3,200 kilograms over 1 meter cubed. It might be beneficial to write it as a fraction or a ratio, so that way when you do your math, you'll see that the units will cancel out. So we do it this way for unit purposes. We're saying there's 3,200 kilograms for every or per 1 meter cubed. Our mass here is going to be 2,000 kilograms. Is our mass 2,000? No, it's not. The mass is 2,000 kilograms. You have to add in the extra unit. Otherwise, it's just a number and not showing your mass. Okay, the G part is done. Your given is done. Now you need to do the U part, the unknown. You don't know, and you're asking for what you asked for was volume. So V equals the question mark. So I know I have 3 units, so I have to find the 2. I'm given 2 of the 3. Now I got to find the third one. So you might know that volume is going to be your well, if you don't remember, let's go ahead and make the triangle. It's going to be M D times V. Now this is a fraction bar. That line over here shows division. Okay, so that's what's being divided. Okay. And so what is the volume going to equal? If I cover up the volume, right here, I don't know it. So volume is going to be mass divided by density. So I'm going to write that in the equation format. So that's just, we got our unknown. Now we need the equation. V equals mass over density. And if you didn't know that already, what you could have done is you could have solved it algebraically. You know that D equals M over V, and so you solve for V. So we'll go ahead and we'll multiply V to both sides of the equation times V, and cross it out, and we're going to be left with M equals D times V, and then we're going to divide D again. That's going to cross that out, and it's going to leave V equals M over D. Okay, if you need help doing that, go back and rewind the video and watch this part again, okay? That will be very helpful. We're going to erase this so we can get back to the math. But go ahead and watch the removing of the variables, okay? So now we're going to go ahead and, we got the equation part down, now we're going to go ahead and substitute. So what are we going to substitute? Again, like I said in other videos, When you substitute an equation, and this process is worth 1 point, you have to show this part right here. You have to show your variables. You have to show your variables here. You have to show your unknown. Then you have to show your equation. Then you have to show yourself substituting it in. So when you do that, you ask yourself, what parts are you changing? We're trying to find volume, so you're not changing that. So you're going to rewrite that down. It's called plugging and chugging. You plug in the new numbers, and you leave the old ones the same. So you plug in volume. You plug in your equal sign because you didn't change it. But did you change your mass? Yes, you did. So you need to plug in your number. And the mass we said was 2,000. Was that the mass? No, the mass was 2,000 kilograms. If you don't have that, then you have the wrong answer. And the density was 3,200 kilograms for every 1 meter cubed per meter cubed. So then I just go ahead into the calculator and I plug that in. I plug that into the calculator, so it's going to be 2,000 divided by 3,200. That's going to give me 0.625, 0.625. So my answer is going to be, my V is going to equal 0.625. Let's erase that so we can get some more room. So my V is going to equal 0.625. Is that my answer? No, it's not. If you leave this as it is, it will be counted wrong, because your answer is going to be in the units of meters cubed. But how do you know that? It has to be in meters cubed. But the question is, how did you get that? So go back to your units. While you divided your math and you took care of your numbers, that's fine. But your units couldn't have been divided because they're in unit format. So you go back up and you realize what you had. You had the kilograms being divided by a kilogram over a meter cubed. That's a number. That's a fraction being divided by another fraction. How do you divide fractions? Well, you simply multiply by the reciprocal. So it's going to be kilogram over 1 times the reciprocal of kilograms over meter cubed. So meters cubed over kilogram. And then what's going to happen? That's going to cross out, leaving you with meters cubed over 1, which is meters cubed. Meters cubed is your answer. So my total number is V equals 0.625 meters cubed. This is my final answer. If I don't have my units, then I'm not acceptable. Well, thank you, and if you have any more questions, please come see me after class or shoot me an email. Thank you.